Get done. All right. I'm just going to answer these first. Name the anion PO43 minus. Is it an expectation that on the quarterly that you know your polyatomic ion? Yes. Yes. This is phosphate. By inspection, you should recognize when you see PO43 minus that is indeed phosphate. This was considered to be like a way too easy mark. This is a pre-ACE level question. 1. That is what they gave it. Yes.
I know you have to memorize it. Yeah. I memorized it.
Yeah.
But is there a way to figure it out without memorizing?
What do you mean?
Like, let's say they just give it to you and you didn't know you were supposed to know.
I mean, they only make you memorize the 8 ions for the most part, so you know it ends with 8. It's got oxygen, and phosphorus starts with phosphate. Like, it's not very, they don't make you know too much with the polyatomic ions here. If you were to do an AP curriculum instead of 8, there'd be about 80 of them to memorize.
That sounds like so much
Anytime
fun.
you go to memorize all 80.
There's tricks.
Just take tips and tricks.
Okay.
There's tricks. All right, so I'm going to go ahead and solve the second one now. What I did was I got the molar mass of NH4 MgPO4. So I'm just going to show what I did. You can check my math, but I got the molar mass of NH4 MgPO4, and then this was no water. This is with water. So to figure out the water, you would subtract, yes.
Phosphorus is 31.
Okay, so this is all by 1. So it would be 137.3. No, it's not going to affect your answer because you rounded the nearest whole number. So 137.3. So with water, 245.3. Without water, 137.3. What's the next thing you do?
245.3 minus 137.
245.3 minus 137.3. So then what number would that give you?
108.
108. That's the grams of water. But that's not the answer. Because you have to change that grams into moles, which would be equivalent to the amount of molecules for each one of that compound, because moles and molecules relate the same way. So you would do that, divide this by 18, and your answer is, that's it. So if you got 6, that's the answer. This is NH4 MgPO4 with water. This is NH4 MgPO4 no water. One of the basic ideas in this class, you're going to see it again in the lab today, is if you weigh something if you weigh a bunch of things together, like let's say you weigh a container with a lid, and then you weigh just the container. If you subtract those two numbers, you're going to get the lid. It's just the missing part that you're looking for. And that's all that's happening here. That you have the hydrate with the water, and then the part without the water. So you subtract to get 108. The reason you divide by 18 is because that's the molar mass of water. To change grams to moles. Yes. Oh, that's a question? Okay. Are we good with this now? Make sense? On the same page? Is this fair game for the quarterly?
Yeah.
We've been went over it for the past week and a half, and you had a lab on it, right? So this is fair game. Through chemical reactions, I'm not going to put concentrations on the quarterly, which is our current topic, but it is going to be in today's lab with titrations, because titrations is a major lab we got to practice. So this question, pretty much everybody got correct, I think, from what I saw. It is the solubility of sulfates. Properties of the elements change down the group. Which periodic property are we observing? Magnesium to barium. Decreased solubility of sulfates. That's a straight up you memorize it thing from the standards. So let's talk. First of all, let's talk about quarterly. Quarterly exam, next class. It's going to be 60 marks. mean? 20 multiple choice, 40 written. That's the spread. 20, 40. That's how the other tests have been as well. That's how all the tests have been. And that's close to how the spread is at the end of the year. So you've got to, for this test, yes. So you can expect 20 and 40 as your spread, 60 total marks. You do not have to get every mark. So you just try to get as many marks as you possibly can. The next thing I want to bring up about the quarterly is how do levels work? And what grade will go in the grade book for different levels? Yes, Justin?
What's the passing grade, the lowest one on the marks on average?
Hold on. So let's talk about levels. I haven't written the test yet, so I'm not going to know the exact number of marks because it's dependent on exactly how difficult the questions are. Because remember, every year grade thresholds change depending on how the world does. But I can give you estimates to work on. So if you get an A level through a C level, what's going to go in the grade book is 110. If you get an A level, a B level, or a C level. And not only will 110 go in the grade book, it will also replace your lowest grade if either of your Unit 1 or Unit 2 grades was lower than a 110. I don't know. So A, B, C. D level is a 90 if you hit a D level. E level is a 75. Lower than an E level, which means fail, means you didn't pass the first quarterly. It's going to be based off of how many marks is where passing is at. And so out of 75%, if let's say the passing was set at 20 marks, then it would be your score, your raw score divided by 20 marks times 0.75. And that would be what goes in the grade book. So it'll be graduated that way. So if you fail, it depends on how many marks you got, how close you get to 75 in the grade book. Does that make sense? Hopefully everybody passes and we don't even have to worry about that. So how does it work in terms of marks? I told you the test is going to be 60 marks, and I know many of you are going to be looking out for that A through C. My philosophy is always, if you can hit a C level, you're very likely to put yourself in a good position for the end of the year. If you're on an E level, you are teetering on the verge of U. And remember, on the end of the year, you're more stressed out. You're seeing brand new questions. These can become used very easily. That's my philosophy. So I want you to aim for a C. That's what I'm looking for you to try to get. You don't have to get it unless that's your personal goal. If your personal goal is, I want to get top in the world, yeah, let's do this. Please do that, of course. But my goal as a teacher is that everybody is aiming at least for a C level. That's why you see me setting it with the extra credit even if you score the C level. So far so good? So where do percentages usually run around? I am going to tell you that so that you're aware. In the past, on the first quarterly, because there's the least amount of material on this one, I do make it a little bit higher, the percentage you need. Typically, an A level is around 50 marks. Typically. It may not be exact. It may be somewhere like 48 to 52. It depends on how difficult the test is. So it's going to be somewhere around 50 marks. 50 out of how many? 60. So you got 10 marks of wiggle room for an A level. And then from there, I go down. E level is usually around 22 marks. And then B, C, and E will be somewhere in between. So usually minimum amount passing is around 22 out of 60. Doesn't sound like a lot, but remember, you got to earn the actual Cambridge mark. Cambridge would have to give you the mark. Does that make sense? All right. So do we have an idea? Do you have a goal? Remember, at the end of these tests, you should start getting in the hang of counting up how many marks you think you got at the end. You may want to write it down just to like compare. Oh, this is what I thought I got. This is what I actually got. So you see if because eventually you're going to be starting to mark yourself. And you should be starting to think, did I get this point? Did I not get this point? As you're going along. And it gives you a good idea of your confidence levels. Quarterly, next class, starting at 12:30, 60 marks. You get 10 minutes to like when you come into class, but we'll be beginning pretty quickly. How quickly will it be graded? Cookie science is happening that day, but I will have it graded before the next class, which means my goal is to grade it on Wednesday of next week for everybody. So it'll be graded, it'll be in the grade book by Wednesday night of next week. I can't guarantee Tuesday because I might be graded. All right, so here we go. Today, what are we doing? You're gonna do a titration today. If you've never done a titration before, you're gonna do a titration today. But beforehand, we got a couple of things to go over. Titration.
Was that the pink thing?
That's the pink thing, but it's not pink today. We're gonna talk about what is a titration, what we'll be doing here, but let's take a look at the actual learning objectives. All right, come on in. Here. So, I am recording, I believe. I'm gonna go ahead and, yeah, I'm recording. So let's go ahead and get started. This standard is the same. This standard is the same as last class. Remember, we kind of rushed at the end. We didn't get quite finished with it. So we're gonna do a couple more examples with volumes and concentrations. You'll also notice that I had put up an assignment, but I took it down. You should have noticed that because I didn't get through solution stoichiometry. So I went ahead, I took it down, and it'll go back up, but after your quarterly exam, so that you don't have to stress about it. However, today we are going to do a lab. We are going to go over acid-base titration, so you're going to need to pay careful attention throughout the class period. And like I said, by 1:20, we'll get to start talking about the lab. Our goals for today is to still continue calculations with volumes and concentrations. Last class, you may remember I gave you a formula. You should rewrite it down. Concentration equals moles over dm cubed. In today's lab, you're going to need this formula. You're also going to need to know how to change cm cubed to dm cubed. So remember that if you have cm cubed, like let's say you have 25 cm cubed, how do we change that to dm cubed?
Move the decimal place to the left 3 times.
Perfect. You want to know this for the lab because you'll be using centimeters cubed and decimeters cubed in today's lab. So write that down just to remind yourself how you change centimeters cubed to decimeters cubed. The other strategy is to divide by 1,000. If you take 25, divide by 1,000, that'll give you the decimeters cubed. The other thing you need to be aware of is that centimeters cubed on our measuring devices are also written as milliliters. So when you get your equipment you're going to be working with today, you're going to read milliliters, and you have to automatically recognize that that's actually the amount of centimeters cubed in the instructions. So you'll see that I'm really tearing this lesson a lot to what you're going to be doing in the lab today. And so make sure you have this written down so you know, okay, these are equivalent. 1 centimeter cubed is 1 milliliter. So 25 centimeters cubed is how many milliliters?
25.
So it goes back and forth like that. All right, the second objective is to select suitable indicators. At this time in life, you will be given the correct indicator to use, but I am going to teach you in a different lesson how to pick from a list. I'm passing you out an additional handout to go in your notes. Please do not lose this because I paid for it out of my color ink. I'm honest. It's expensive. Ink's not cheap.
No.
This is a selection of the indicators you're going to be using this year in your labs. Here you go.
Is it 1 per person?
1 per person. You keep it. Here you go. You keep it. It's for you. It's a gift. It costs money. It really is a gift. This is a selection of the most commonly used indicators. By the end of this year, all right, Max, need your attention again. So, By the end of this year, we will have done labs with all of these. These are the main indicators you're going to be using. I would suggest having this on hand because for these specific indicators, you will not be told the color change by Cambridge most likely. You are expected to memorize it. So I want you to pay careful attention to the middle. The middle is where equivalence is.
Is the lesson about
Yes, everything that goes into it. And so we actually, in pre-ACE chemistry, we already worked with one of these. That was dramatic that I wanted you to remember. Phenolphthalein starts as colorless and ends hot pink. But if you get hot pink, the middle point is actually light pink for phenolphthalein. That's the color you're looking for. So the light pink that's right after, the one that says none, that's actually the color you're looking for there. Today, you're going to be working with methyl orange. You may want to write on your regular notes. So when we get to the lab, we're actually going to be working with methyl orange. So we'll be talking about that in a little bit, what you're looking for. So let's go ahead and go over what we need to know. We've got a couple of math questions we need to get through that we did not get to finish last class. And then we are going to go, like I said, we're going to try to start this lab by 1:20 p.m. So a lot of what I'm teaching today is to help you be successful in today's lab. Once again, I will not be putting concentration math on the quarterly, but it's still on Unit 1 and you need to know it, and it's super important for paper 3. You've got to know how to do it for paper 3. So I'm not going to give you any homework today, by the way. Your only homework is to study, revise your first 2 exams, make sure you know your periodic trends, make sure you know your definitions, all the objectives we went over, so that you are well prepared for the quarterly next class. You want the quarterly to bring your grade up or stay the same, don't bring it down. So do as well as you can. All right, so here we go. This is an equation we went over last class. I just reprinted it. It's the concentration equation, moles over decimeters cubed. Remember that when concentration is presented to you, it could be presented to you like this. What is this supposed to be communicating to you if you see this? You are being told, right? Being told concentration. This together, when you see mole DM minus 3, you are being given the concentration, which means that they're either going to be asking for the moles in the question or they're going to be asking for the volume. Volume is in DM cubed.
So sorry for another interruption. All testing students should be back in 6th period at this time. All students who tested, we are done. Thank you all for such a great 2 days of testing. Ms. Goodman's class will remain with Mr. Morales and Mr. Labadee's sub. Thank you. Have a great day. Last call for homecoming field trip forms. Last call if you are missing a signature. Get that signature this weekend and Monday 7:30, not 7:31, 7:30. We're closing it out. Thank you.
Okay. Do you need me to go back? So just so you're aware, the first thing you're going to be instructed to do today is make a solution. You're going to have a solid. You're going to have to measure the mass of that solid into a beaker, dissolve it, and then you're going to be making a solution. I told you about this last class. You need to make sure when you make a solution, you get the bottom of the meniscus exactly to the line. If you go over, that means you restart. And so that's why I'm going to give you time to do the lab today, just in case mistakes are made. So going into what we're going to be doing. In a titration lab, what we're actually doing is we're going to be, the first type of titration there is called an acid-base titration. And we'll be neutralizing an acid with a base or a base with an acid. And so the point at which the neutralization occurs, we call this the equivalence point. This is when our moles of acid equal our moles of base. And this is really when we can use a balanced equation. And so you may want to point out the equivalence point is when we can use a balanced equation to solve questions. Yes. you may have came in after I said there was a quizzes that I took down. I'll be putting it back up next week. There were 3 quizzes. I took one down because we hadn't went over this quite yet. It's not going back up till next week. Until after your quarter day. It won't be due till like at the end of next week. So don't stress out about it right now. So what about the math? What is the math going to look like here? And actually, it was the math of that assignment, which I know some of you were confused about, and I realized that evening that I had not yet, these were the last 2 questions from the last lesson that we didn't get the time to do. So we're going to do them now. This is an example of an acid-base reaction. Can you point out what your acid is? Can you point out what your base is, first of all? In this equation, what's your acid? Hydrochloric acid. This is your acid. Remember, acids always have H plus in the front for the most part. There's 3 you gotta memorize: hydrochloric, sulfuric, and nitric. And SrOH2 is your base. What we mean by acid neutralizing base or base neutralizing acid is when an acid and a base react together, you always make water and you make some sort of compound, ionic compound. That's called a neutralization reaction. So today the reaction you're going to be doing is a neutralization reaction in the lab. But let's take a look at this neutralization reaction first to see what kind of math that you could be asked for here. It tells you have 25 centimeters cubed of a solution of strontium hydroxide and that you exactly neutralized that. That means that you got to the equivalence point, the moles of acid equals moles of base, when you have 15 centimeters cubed of a 0.1 molarity hydrochloric acid. The question is asking you, what is the concentration of strontium hydroxide? Where do you think we should begin? And I did give like a whole blank slide here if you need to work out how to do the math. Where shall we begin? We want concentration of strontium hydroxide, right? So this is what we want. So start with the formula. I agree with you. Not that formula. I don't agree with you with that. Because that's a dilution and this is not a dilution. I would start with what we have 2 pieces of information for. That you have an equal amount of acid and base. So that means you can use this balanced equation. I don't know. Yeah. But before that, I have the volume of hydrochloric acid. Yes? I have the concentration of hydrochloric acid. What can I get from that information? Start with concentration equals moles over dm cubed. So we're going to start with HCl because we have 2 pieces of information for HCl. Because I have 2 pieces of information, which means I have 2 out of 3 parts of this formula. I'm going to start with that. Plug in what you have. What do you have? I have to go back and forth between the slides. I have the concentration and I have the volume. However, is my volume in the correct units? And we should quickly, and this is why I said we got to quickly do it, change centimeters cubed to decimeters cubed, right? So I'm going to correct my volume to the right unit, and then I plug it into the concentration formula. That sounded like it. So 0.1 equals moles over dm cubed here is 0.015. Marinate, does that make sense? Marinate means let it soak. Does what I put into this formula make sense to you? I just plugged in the concentration of HCl and the volume of HCl. So I hope to achieve from this the moles of HCl. Yes, Nikki. I'm going to write 0.0015 because I don't want to work with scientific notation. I don't want to do that. 0.0015. is my moles of HCl. How do we get that? Multiply the two values we know, yes. Multiply both sides by 0.015. So far, does this make sense? I did 0.1 equals moles over 0.015. Then you multiply both sides by 0.015. This gives me the moles of HCl. Just to repeat what I did. You don't have to write this. I already did that here. Repeated it, just in case. Breathe in and breathe out. Are we good so far? All right, moles of HCl. At neutralization, you can use the balanced chemical equation. So what can we do now? According to our recipe, 1 mole of strontium hydroxide has to react with 2 moles of hydrochloric acid. So far, so good? 1 for 2. So the question what we're looking to try to figure out is what's the concentration of strontium hydroxide? That's what we're trying to figure out. Right now, where we're at is we have the moles of HCl. So what can we do now? So my step 2 would be to convert HCl to strontium hydroxide, which is what the question's asking for. It's asking for strontium hydroxide. We have HCl. So go from moles of HCl to moles of strontium hydroxide. Because at neutralization, you are reacting your acid and your base, and you've got these exact amounts. This is your ratio. This is your recipe. You can only use your recipe at neutralization. So what does this say? 1 strontium hydroxide requires how many HCl's? 2. So I've got 0.0015 HCl's. How many strontium hydroxides? What would you do? Divide by 2, correct. And I'm just going to show the correct canceling. What we have to plug in is that there's 2 moles of HCl for 1 mole of strontium hydroxide. So what this means is 2 moles of HCl goes at the bottom, and 1 mole of strontium hydroxide at the top. Put an invisible 1 on the bottom there, and 0.0015 divided by 2 is like what? 0.00075, something like that. Double check my mental math. Point 0.0015 divided by 2 is 0.00075 moles of SROH2. Yes? Do we have enough information with that to get the concentration? I've got the moles. How do I get the concentration of SROH2? I need the moles and I need the concentration. I need the moles of SROH2 and I need the decimeters cubed of SROH2. I just found the moles. We just found the moles. That's what we did. Do we have the volume of SROH2 given in this question? But moved over to 3 spots should be 0.025 decimeters cubed. And when you're doing the math like yourself on paper 3, you can automatically change your CM cubed over to become DM cubed. So you could use the formula correctly. So then this is going to be 0.00075 divided by 0.025. And that gives us 0.03. SROH2. This is actually the kind of math you're going to have to do in this lab, which is why I wanted to bring it up. You're going to have to use the concentration formula, and at neutralization, you can relate the moles of acid to the moles of base to find the concentration of an unknown solution, which is the idea of a titration, is you're going to be given a known solution, in this case that's hydrochloric acid, and you're going to be given an unknown concentration, which you're actually going to be responsible for figuring out. So this is the kind of math that you're going to need to do. Now, I do want to say that last year, if you did have me for pre-ACE, I gave you a trick way to solve questions like this, and it is Cambridge authorized. But I want you to finish writing this down because this is the step-by-step method, and the way Cambridge paper 3s are, they want one step for 1 mark, and they tell you, get the moles of this, get the blah, blah, blah. And you'll see that in the lab. So you need to have the step-by-step method written down at least once because it's going to help you with the lab exercises. But let me give you the shortcut method, which is actually very similar to dilution of solutions. It's not exactly the same, but you may recognize this. So we can do the same thing with this formula. It may ring a bell. N1, M1, B1 equals N2, M2, B2. Does anybody remember this?
Yes, without the end.
No, you don't remember the N? Does anybody remember what the N stood for? What? You remember those letters in that order in some case? One side would be for the acid, and the other side would be for the base. You may want to write that down. Little n stands for the amount of H plus or OH minus in the chemical formula. So this is the shortcut method to solve this question. Write it down because sometimes you could use the shortcut method, and in the homework that you'll get next week, you could use, for a lot of the questions, the shortcut method. So we're going to reread the same question and do it again with the shortcut and see if we get the same answer. But you can't always use it, so that's why you have to have the full. On a paper 3, when they ask you for each step, which is what you're going to see when you get the lab, they're going to first say, you have this amount of centimeters cubed with this concentration of hydrochloric acid, find the moles of hydrochloric acid. Like that's how the lab is. So they're not going to go directly to this final question. They're going to ask you for step 1, then they're going to ask you for step 2, if that makes sense. But they're going to ask, what is the concentration of HCl?
The questions are going to guide you.
They'll guide you. So the lab guides you through the process. Yes. Yeah. That's what I mean. It guides you, but you will have to go through that set of steps. That's why I wanted to show it to you. All right. So, but if you were just asked this directly, you can use a shortcut with this information. Acid. What's my acid? HCl, right? How many H pluses are in that chemical formula for HCl? 1. So you write 1. Because HCl has 1 H plus. Because HCl is 1 H plus. You don't have to do the mole to mole ratio because when you put the little n's for 1 and 2, it automatically gives you the ratio. That's why it's a trick. You see what I'm saying? Molarity. You just got to find the number for HCl. What is it? What's the molarity? Yes. Volume. Hey, you should probably change it to decimeters cubed just for good measure. What is it for HCl? 1 times 0.100, right? Technically, times 0.015. That's my information for the acid. And now let's take a look at our information for the base. What is our N2? Which is our amount of, for the base, the amount of OH minus in the chemical formula for the base. 2. Because the base is strontium hydroxide. Yes? 2 OHs in that formula. Our second molarity is molarity is concentration, right? So isn't that what I'm looking for?
What is the N?
The N is how many OH minuses or how many H pluses you have in the chemical formula, because remember the moles of H plus have to equal the moles of OH minus at the end when you work out the equation. And then B2 is what here? 0.025. Now solve for M2. See if you can do it. You gotta work out the math now. So it would be 1 times 0.1 times 0.015, which is 0.0015 on the left side. 2 times 0.025, which is 0.05 times M2. And then divide both sides by 0.05, and guess what? Same answer. This is the same answer we got from that 3-step process, right? 0.03. So once again, there's 2 ways to do this. If you've been presented with all the information at once, you can use this shortcut formula to solve for any missing piece. Yes, Hakeem.
What did you find?
0.03, I divided 0.015 divided by 0.05 because 2 times 0.025 is 0.05.
So you divided the sides by
0.05 because I'm trying to solve for a molarity. Decimals, yes. All right. So I just wanted to bring up what you do here because in order to be successful with the titration math, you need to have some practice with this. But I'm not going to spend much more time here because, like I said, today's main goal is actually to get through a titration lab. So what I would like you to do is, for the second question, see if you can use the shortcut method to solve. See if you can use the shortcut method to solve this question. The other question, another example. You've got 20 centimeters cubed of a 0.4 molarity sodium hydroxide. You neutralized it with 25.25 centimeters cubed of sulfuric acid. Calculate the concentration of the sulfuric acid. Let me help you out a little bit. What's the chemical formula for sodium hydroxide? NaOH, which means that this is going to be 1, right, for the base side. And what is sulfuric acid? Something that we've got to memorize is what's sulfuric acid? Sulfur. H2SO4. So this is 2. Figure out the rest. Figure out the rest. Let me see your answer. Once you have an answer written on paper, show it to me. And then the next thing is actually really just talking about the lab and getting started with that. on the wrong side. Maybe. Oh, no. What you put on the wrong side was, this is the information for the acid. Yeah. What's 8 times 10 to the negative 0.008? Thank you. 8 times 10 to the negative 3, you said? That's correct. You got it. Put a box around it? That is correct. You got it. Put a box around it? Yeah, you got it. Put a box around it. Yay! All right, so I'm just going to fill in the rest of the numbers. This should be M1, and B1 should be 0.02525. On the other side, volume should be 0.02. And your final answer, if you got it correct, would be 0.158. That's your final concentration. So just plugging in the answers correctly, then multiplying everything on this side, multiplying on this side, and then dividing both sides that look here. So we're going to go ahead and get started talking about the lab so we can have enough time to do the lab. Let me be clear. Your goal today, in order to get full credit for today's lab, is number 1, to make a solution without going over the line. And second, to get the orange color twice within 0.1 centimeters cubed of the other reading.
Within what?
0.1 centimeters cubed. So we are about to begin. No, we're not moving yet. I have already set up the labs completely, and all the papers are at the tables in the back. There are 9 lab stations. There are 18 of you. So when it's time to move, you're going to be 2. So you're going to operate in pairs today. So yeah, there's 9 tables and 18 people. So it's going to be 2 people per pair, pretty much. So the lab you're going to do today is going to be interesting because you're going to be reacting a metal carbonate with an acid. This is the general reaction. So this actually does have to be memorized. This is a quite common reaction. It is a metal carbonate with an acid. It is a double replacement, but it has special products. I'm pretty sure in last year's pre-ACE group, I did tell you had to know this. Whenever you make a double replacement reaction and you make H2CO3, it actually makes water and carbon dioxide. And you should know this. Carbon dioxide and water. So this is the generalized reaction for a carbonate with an acid. Yeah, you're going to need to know this. You just have to balance this. I'm pretty sure I
Carbonate, sulfates, and
balance this. You need to balance this. This is for, I didn't balance it when I was writing it out last night, so make sure to add the 2's there. Because you will be asked to do an ionic equation later on in the lab, and that's part of what's here. So, this is the reaction. This is actually going to come to you as a solid. And you're going to have to dissolve the solid to make a solution. And then you're going to titrate this solution against acid. The acid you're going to be working with today is hydrochloric acid. It is not a very high concentration. However, safety-wise, what do you see me wearing? Gloves. It sticks. You wear gloves, and you should wear protective eyewear. It can be glasses if you wear glasses. If you don't wear glasses, then it needs to be goggles of some sort. It could be the thin goggles, but either glasses or goggles. You do need to have some kind of protective eyewear. All right, this right here is just me telling you today we're going to be working with methyl orange. The middle color for methyl orange is actually orange. I got the door. If your solution is basic, it'll be yellow. Like, you know, things that look yellow, like yellow solutions. I don't want to say. So you're going to start off with the yellow solution when you add indicator. Because you're going to have the carbonate in here. If you go too far today is red. So it's yellow to red. You're going to be going this direction because what you're going to be adding the indicator to is a base 6 solution. So you're going to start with yellow and you're going to end with red. But if you get red, that means you went too far. The actual color you're looking for, and that's why this is an excellent indicator to work with. It literally tells you what you're looking for in the name of the indicator.
So which circle would you?
Orange. The color is going to be orange. So like, this would be good. Anywhere in here would be good. So why does it show different than what you see in the middle here? Because this is at a pH of 7. And methyl orange will give you the range of 3.1 to 4.4. Why does that matter? Because what you're going to be working with today is a strong acid and a weak base. And that means that the pH at equivalence will actually be less than 7, interestingly enough. You don't have to get too much more into detail than that to understand today's lab. You just have to know what you're using today is methyl orange. The color you're looking for is orange. Looking for orange. So this is the data table that has to be memorized in May. You have to, but like when we take paper 3 in May, you have to memorize this titration data table. When it comes to practicing for the labs and it's time, so for today you can bring your paper with you to write your table correctly, because obviously I don't expect you to have this memorized right now. So you can bring this paper with you to your lab so that you can write out your table correctly. The portions of the table, and so today you get a crutch. Next time you do a titration, I want you to do it without the crutch and try to remember what you need. So the first column is going to be initial volume. The second column is final volume. And the third column is the volume of whatever FB you're adding. Write FB2 here because that's for this lab. So whatever FB you're adding into the urette is what you're writing here. Now what does FB mean? That's going to be what's labeled. So on a paper 3, you're either going to see FA, FA1, FA2, FA3, or you're going to see FB, FB1, FB2, FB3. Cambridge may or may not tell you the identity of these substances. You have to read the lab paper to know if they told you what it is. But this is whatever is in the burette. What's the burette? It's the long, it's the long piece of equipment. The initial volume for burette, do you remember what it should be? If you forgot, it's fine. It goes down to 50. It actually starts at, if it ends at 50, it starts at 0. So you should remember that your initial volume is 0. However, it doesn't have to be. If you want to be spicy, you could start your initial value somewhere else. However, recognize that it's the difference between your final and your initial volume that give you how much was actually added to change the color. So this is when the color changes. You only mark the volume at which the color changes. At which color is orange in our lab. So which the color changes, which for our lab today means we're looking for that volume to be orange. Some important things here. Before you do a real titration, you do what's called a rough titration. We call that a practice run, meaning you just go through the process, you get the color to change quickly, and you stop right when the color changes, and you're like, okay, record that volume. That way, next time you do a titration, you know to just stop a couple centimeters cubed beforehand and go really, really, really slowly. You've got to be accurate on your real titrations. And so you're going to, hopefully in your first 2 titrations, you get volume added that is within 0.1 of each other. That's what Cambridge is looking for. So for example, if the color changes here and it's 24.5 and here it's 24.6, this is example data. 24.5 minus 0 is 24.5. 24.6 minus 0 is 24.6. If you get this, you stop. You're good. If you have two titrations where the color changes within 0.1 of each other, you stop. You don't do a titration 3. If you actually do a titration 3, you lose a mark. If your first two titrations are within 0.1 of each other, yes. They will always be the same if you start your initial volume at 0 every time. But if you decided, you wanted to run it quickly and you didn't want to like go drop by drop to make sure it was 0 to start at, you're like, it's 0.4, let's just start there. You would do a subtraction to get the final amount. Because it's how much was added from the burette to the flask where the color changes that we're looking for that volume. That's why you have to have a column for volume of whatever it is you're adding, because that's the amount of solution that made it into the flask. And so the next thing to be aware of, and there's a mark for this, is when you record your readings, you have to record to the nearest 0.05. This is something that students sometimes have difficulty remembering, so you want to put stars around it. This means the way that I recorded it here is good. This is good. This is good. This is wrong. This is wrong. When you record your volumes, you have to round to the nearest 0.05. So you're estimating the last number. You always estimate the last number when you're recording volumes. And you estimate with either a 5 at the end or a 0 at the end. So if you use any number but 5 or 0 at the end of a reading, guess what? No, you've lost a mark. But there was a mark for that. So that's something you need to be aware of when doing titration. Now, before we get started, at this point, I know we're going to get started very shortly. At this point, I would like you to get into your pairs. Grab gloves and goggles if needed. I'm going to show you real quick the design of the lab for those who need a reminder or have it ready. Grab gloves and goggles and bring chairs. Okay. Gloves and goggles.
I mean, I really gotta tell you.
Gloves and goggles. Most stations have 2 chairs.
That's my favorite.
Okay, let's go.
Do this.
Then you're going to be seated. And before you're starting, I want to just give you a couple points of guidance. So make sure you're getting your gloves and goggles, you're getting seated, and I'm going to model a couple of things for you before you begin. Okay? You may want to bring your notes with you because you need to make a data table in your actual lab. And you're allowed to have the notes as a crutch. You can use it to help you write your columns up properly. Any more meeting books? All right, grab gloves, be seated. You need protective eyewear. Find your paper, write your name. Don't write anything else on it yet, but write your name. All right, take a seat. Do not start anything yet. All right, everybody go ahead, grab your gloves and goggles, take a seat. I'm going to show you real quick what to do. So you're going to need to pay careful attention. Okay, called a volumetric class. You may remember this has one job. You use this to create your solution always. If you have to make a solution, you're using this. It has one job. It can measure one volume. It measures one volume very accurately. If you miss the mark, that's where you gotta start over. So let's talk about where we're gonna begin. When you get a Cambridge lab, the most important thing you can do is read instructions. At the beginning, it tells you what you have, what you are given information for, and pretty much what you're looking for. It tells you FP2 is hydrochloric acid. So now you know in beaker that is labeled FP2, you have hydrochloric acid. Not only did they tell you what it is, they told you the concentration. That might be the only place they mention the concentration, and you're going to need that for the math later. So pay careful attention. FP3 is a metal carbonate. They didn't tell you what it is. That's why they have the letter X. So you're going to have to figure out what is X when you work out the math at a later time, not right now. Today, remember, the goal is you're going to make a solution properly. You got to show it to me. You got to prove to me that you got it. And you've got to get the 2 orange titrations within 0.1. That's how you get a full grade on today's lab. Got it? We will work through the math more on a different day. But that's where we're going today. All right. So let's talk about accuracy. How can we earn accuracy marks? So when you read your instructions, you need to make sure if you're making a solution, you dissolve your solid well. So you're going to be told in this lab to weigh a cup that has FP3 in it. FP3 being your metal carbonate. If you are told to weigh something, should you be writing down the weight? Yes, so you write down the mass of your container with FP3. And then what they're going to tell you to do after that is to pour FP3 into a beaker and weigh the mass of the container without FP3. And so you're going to need those 2 measurements. That's going to go in your top area after you do your initial thing. There's an area at the top where you write your mass of the information I've written there. And so then you're going to dump your FP3 into a beaker. It says a 250 milliliter beaker. Find your 250 milliliter beaker. It says 250 in the front. Some people get confused because it only actually measures to 200, but it's a 250 milliliter beaker. You pour your solid in there, and then it tells you in the instructions to add 100 centimeters cubed of water. Now what I'm telling you is for accuracy, you have to dissolve this really, really well. What does that mean? We practiced dissolving last class. Should you see any solid particles when you're done dissolving? So you've got to dissolve it thoroughly. This is the #1 mistake students make in making solutions. They get impatient. They don't dissolve everything, and guess what happens? Your answers are all over the place later on because you didn't dissolve everything. And so it's not homogeneously mixed. Do you remember homogeneous? One page. So once you are confident you've dissolved everything, you're going to use your volumetric flask. Identify the volumetric flask. You're going to use this to make the solution. When you make the solution, you can use a funnel to put your solution in if you don't want any to drop. Remember to clean this before. I have a funnel at every station, so some of you read it has not been used for anything yet. So you can use your funnel. You just have to clean it out with water before you use it for anything else. And so then you're going to pour into your cup, your solution. This is what the instructions say to do. Intentionally, it should be less than 250. You agree? Where do I have to pour with water now up to? I have to go up to the line. That's the first thing you have to show me. If you go over, you start over. What is the best practice here? When you get real close to this thin point right here, the bottle, we say the bottleneck, what should we switch to instead of just pouring? There's a disposable pipette, instead of adding like you see me doing here, when we get to the neck, what would we do? What else do you see me doing? You see me putting water in the speaker. Why am I doing that? It tells me on the instructions to do this. Why am I doing this? Oh, I went over. So I would have to start over. So when you get to the neck, what should you switch to? Pipette. And you use this to go one drop at a time. Once you made your solutions, and I did this earlier, then you're going to use the pipette to take the solution out and put it into a conical flask. At this point, when you take this 25 centimeter cube pipette and you add this into the conical flask, you have to add indicators. The indicator has to go into the conical flask. What color is this, by the way? This is yellow, not red, right? Not orange. This is yellow. That's your starting color today. So when you have this conical flask that you put your solution that you made into, if you forget to add indicator, it's going to be colorless. And guess what? You'll never see a color change. No indicator, no color change. It's a mistake. I'm saying it on purpose because I've seen students do it. You will sit the whole class period and be like, Miss Lee, I never got a color change. I used all 15 milliliters. Like, here's the indicator. Oh, it's red. Because you went over. So don't forget to add the indicator. Once you have your base in here, you're going to put FB2 into this burette. Before you use your burette, you need to wash it. How do you wash a burette? So you've got wash bottles of water, and you've got an unlabeled big beaker. I'm going to give you an unlabeled, or it might have a label. This is your base beaker, meaning that anything you clean, all your cleanings are going to go in here. So to clean that's to label your flask. It'll say to label your flask later on. So to clean your burette, all you got to do is take water and go like this. See what I'm doing? So first you must rinse your burette with water. Then you put a little bit of what you're going to put in the burette. So when you read the instructions, it'll say you're putting FB2. So you rinse it as well with FB2. Make this note if you need to. When you rinse your burette, you first rinse with water to clean it. And then the last solution that should be in here is the one you're going to actually use. Now, when you're going to add FB2 to the mark here for 0, should the lever be open or closed? What's the difference between an open lever and a closed lever? Open. Closed. So make sure all your levers are closed. Check your levers, see if they're open or closed. Close them if needed. Yes, question. Is what? You need FB2? I have some for you. All right, so you're going to add FB2 here. You're going to add your base into these conical flasks according to instructions. The titration happens when you are adding FB2 into this solution, the one that has your base in it. So you're adding acid to base. When you do your trial run, your rough titration, you can go quickly. Meaning, in your trial run, you can add, and I'll just do one real quick. What should I do with this? Should I put it directly on? Should I clean it? I should clean it with a little bit of water. Before I use my flask for anything or anything I have, I should clean it. Now, I need to add FB2 to here. Guess what? You can actually take this off.
Yeah.
And now I'm going to add my FB2. As long as this is closed, if you're short especially, you may need to do this.
You should have told us to share it.
I did not.
Portia, you're short. I feel so bad.
How did the titrations get out?
Yeah, they did.
Okay, so notice what I did at eye level. I held it till it got to 0. Now I'm going to take I'm going to show you the rough titration real quick. In a rough titration, you go quick, just to figure out the area at which the color change happens. So note how I'm going to do it. I already know from earlier. A rough titration should not take you any more than a couple of minutes, like 1, 2, 3. If it's taking you very long, then you do it. Okay, what color is this? Pink. So is pink too far? Yes, because pink is like a lighter red. I just put less drops of methyl orange. This tells me that this happened at 24.40. So for my real titration, what should I do? Go fast until maybe 20, 21, and then go 1 drop at a time until you get to orange. One final note. When you add your indicator, it really doesn't matter how many drops you add, but add the same amount each time so you see the same color each time. So my suggestion is add 10 drops. That's my suggestion for what we have. Yes, Justin?
And you add the indicator once you have everything.
In the codable class. Once you have everything that's supposed to go in the codable class, make sure the indicator's there before you start the titration. If you don't do that, it will be a bad time. All right, good luck. You can begin, start reading your instructions and writing everything down. You're going to show me your main solution that it didn't go over. Or you got to start over. Yeah. You have to write for the math here and then the titration table. Make sure to write down your masses because you will need the math on a different day. You're not doing any math today, just write your measurements. You're just doing the experiment. What are we trying? What? This is the volume. Then you weigh the container again. Without. Do you want to do that? Yeah. Well, in the I would weigh. Why did I get this class together? Yeah, you don't have to be like super specific. So like around 105. The important thing here is that around there. Yes, there. Alright. You gotta stop that song. Alright, remember I just want you to do 2 things today. 1, make a good solution. 2, Alright, now, put your clean up, and then water goes in here,
Or do you want me to do it?
like, it can go either way, but. Alright, so this can go here. Yeah. All of that in, and then water. If you need my assistance during your exam, I am here to help.
I looked away for 1 second.
I have some for you.
Yes, I made a mistake.
Start over. So that means you gotta dump that out. You can dump it out into your waste speaker, just to bring up. What's in your waste speaker? Let me give you a new MP3. You gotta start over.
You do it next time, okay? I looked away for 1
Alright.
second.
No worry, other reason for you, I'm just sorry.
Yeah. This is why I told you to do it. I don't have steady hands. Did you bring an eraser?
Right. Hang on, you've got part one done. Part one done. Now it's time for titration. Yes. So your table's good with part one. Yeah. Perfect. Part one done. Part two done. Okay. A little bit more. The bottom of the meniscus right now, you have the top of the meniscus. You have to read it at eye level. The bottom of I don't know. Yeah, the water is there. Yeah. All of that is in there.
You want me to do this time? Because you started last time, so I'll do this time. You don't.
Right. Water already? Yes. Perfect. Alright, part one done. Make sure you put the thing on it. You should later look straight to tell you FB5. And you're ready for titration. What? That's conical flat. No, you basically, when you make a solution of FB5.
Solid.
Label this FB5. Okay, I've got a Sharpie there. You know what's yellow? The other way.
Because it felt like it was going too slow.
Alright, one drop at a time. You want to go one drop at a time? Right? You get a little pipette? Right here. Who's that?
So that makes sense.
Reach that gray line and eyeball it on. Okay, whatever. You can add it directly to your Alright, don't rush making a solution. You want to make sure you don't go over. Because then you have to start over. It's the real bottom line, right? It's you can you're good. Okay. No. This is all you have to do is says I will always do one drop. You want to add one more drop? Yeah, you can add a drop to the soft if you want. One drop. Okay, because I took out one drop. So one drop. Alright, perfect. 0 now. For your rough titration. And then you just transfer it over quick. A little will go, usually you go a little over it good. When you take it up, see where it goes. So go like that and then transfer it over. Okay. Like have this right next to it. Yeah, move it down. Oh, yeah. Okay. Label it. Yeah, coming out. Oh, you need more water. Gotcha. 10. I suggest 10. Of water, yeah. I suggest 10. To get a good clear color, yes. Alright, you can put the water.
Yes.
Why is it people already?
I didn't think you would go so quickly. I did. I was exploring. I looked away. Something.
Question mark?
No. What? What? FP2 is in here. Why would you add acid? Clean out with water. React this with the acid. Did you use this to add 25? So this has to be cleaned as well.
make us restart. Because I'm the one in a lot. We just want like a fake
This, yeah.
I drop.
Can you hold this? I'm gonna. Yeah, I mean.
Slow down. No. I don't know. This is fine. It's okay.
Yeah, perfect. Alright, so moving forward. This you should label FE5. Because that is an instruction to FE right there. Slow down. No, okay. You need more water. You're at FE3. You need more water. All right, you've got 20 minutes to do your titration.
That's not my fault. Yes, it is. It's not my fault.
Get your rough titration done. Get that original. All of it? Yes.
We're supposed to rinse out water, right? How much? All the way to the top? Do we rinse it out?
All the way.
Do we rinse it out?
Yes, you rinse it out first. It's like not after like I'm up into it and like get everything just me and and whatever. Yeah.
It looks clean. I mean, it's not like this. Really water droplets. Okay, I'll wait till like 20 minutes. I'll tell you when you get there.
Yellow.
I think, right? Wait, Alina,
What?
are we supposed to fill it up all the
All
way?
right, you should try to get the orange color at least once today before leaving. Yes, this is good. This is the control class. Damn it.
I the
This
teacher.
good, miss? Miss.
Okay, you did it. You did it. Use the pink pen. No, can we use that? Wait, can we use the pen? It's fine.
Is that FP2 or is that water? Okay, so that's the FP2 water for cleaning. FP2 is like in here and then
where we just did the right in there.
that's because it's 17. You get it. Jesus. All right, you know what? Good enough. Okay. We'll get more seconds. Yeah.
That's supposed to be FB2. Yes. Don't waste it.
There we go.
I are right on this.
Okay.
I stopped it. After it opened, air came out.
Write down the number you got. That's all that titration. What number do you see here? The nearest point 05. Write it down.
Just make it a 0 right now.
Orange.
One more.
We need to watch the iPad.
Why? Hold on, here we go.
Yes.
Is that good?
This has got to dry out. And we'll do that.
Okay, no.
This does not.
Fill the beer and then I
Alright.
This is the combo flash.
That's the conical flash.
Point. It's not on here. It's on there. One of those things. It's one of them. 25. Does it have a measurement? If it doesn't have measurement, obviously not that way. Start.
But, well, the idea is that you might also have a background.
There you go.
So like make sure all the liquids are. Now I think the top up because it's going to go faster. That's what I do, and then I put it back on. Thank you. And then we have to add 10 drops of that. And then you can start the titration.
No, I didn't. Even told you what red line.
Comparison.
Let's keep on. Yeah. Squirt a little out and then keep it all the way back in.
Oh, that's pretty good. Now, when you're at 0.05.
Go a little, I think that'll go all the way back in.
So you're gonna write that down
Why
as your
keep it all out?
So write that down as your rough. And now you're gonna do another picture.
Go all the way.
Alex,
No, that's, okay, actually, I did 21, 23, so read it backwards. And then up. You can write 23.80 or 23.8.
It's like you
Five or
almost
four. Now, add the three. But I have to answer this. See what I'm saying?
Why'd you put it on board?
Your left brain any of those numbers. Like, none of those are wrong. It's just whatever your best eye estimation is. Just to do another one. All right, table one. First one got that successful orange color. Great job. Do another one. That's your rough titration. So now you start your accurate. Remember today we're on your 20th month. You're just practicing titration. What is you should
I can do precise.
Yeah,
No, just empty it. She knew. Why not start the point? Go back down here and start taking it out.
put the indicator. Now put the indicator. This is so realistic. And you have to make the part where it face matches. However, you have to add that. Now to help you, you may want to feel like you're putting your fingers in here because it's kind of hard to do. Good, okay, that's a rough translation.
okay, so 30 is good.
Not the good face.
So, the bottom, yeah. All right, you got 10 minutes. Try to get the orange color at least once. Be successful today. We do this again. We're doing math another day.
Like, she said 10.
You were just making
It is 10 drops, right?
and Yeah. Alright. This thing. Snapping yours just to make sure you did because you did it. On the first one. First try. Alright, when you get the orange color, let me see. And let me see your ball so I can stamp your work. You get it before you leave.
Rough titration.
You got 10 minutes.
Try to get the orange.
Yep.
Yellow.
Yeah, you gotta be going. Like,
Here, you do it. You're better at this whole precise thing. My answer too big.
it's a rough titration. You don't have to do that, right?
That's the yellow.
So you do it again. And then you do FD5. Yeah. Yeah.
Well, 13. Okay. Now stir. Is that orange? Okay, then go to 14. Don't by like twos.
If you get the orange color, show it to me.
Still yellow. Oh, like 16.
So you gotta stop a little bit before that.
Oh, yeah. 28.
What?
28. And then 18. And then 18. That's
It was 28
I jumped.
18 on that. Yeah, it's not enough.
That's like yellow.
That means orange. Oh no, you play after it. I would bring this up a little bit. Yeah.
That seems kind of orange. A little more. Now just increase by 1.
You're close though.
Increase by 1 now.
If you get the orange color, raise your hand. Let me see it. How many did you go? That's a problem. You put FB2 in here. And you put FB5 in orange or yellow. Something special. I don't know what.
That's kind of orange. That was orange for a That's
Try it here.
it's me. That's not my fault. That's not my fault. Oh, it's like 23. It's like 23. Why? I didn't think it would change on us.
I don't think, that's the problem. I can tell you that.
That's someone's fault.
So if we had enough time.
Whoever was dumping it should have probably been there.
This is yellow, right?
Yeah, this.
That's yellow.
You got big.
So you guys are rough, write your rough number down. If you have enough time, try to do it 4 times before.
Oh, empty it out and do it again.
You got another flask there, no?
Oh,
Good afternoon, Go Live. I'm Lee, your access announcement.
yeah. Use this one.
Please remember to check your camera channel daily and report to the Just make sure your audio is on Also, please wear your student ID badge around your neck at all times. Actions will only be issued to students who do not adhere to the Please remember that you must check your ID every day. If you lost your ID, the cost for replacement is $5. If you store a replacement ID, you must pay for your OC. Students who have unpaid balances will not be allowed to participate.
Once you've at least completed a
Tickets are on sale now. They are $50 now until October 31st. The price will rise afterwards. Bagging your bill out at the spot at the end of your
Yeah, there's a button at the bottom.
Daryl Delgado, report to the main office. Attention students, if you purchase a homecoming card, must
Good job. Collect your papers. Don't worry, we'll do this again.
every morning at 7:30 a.m.
On the back. It should be on the back. That's where you can write your case. You're not gonna write it.
State's government's
You'll get
office.
more time next time. No, we'll do the 21st. So like, what do you do?
We have to run.
Alright, if you got another color, show me. Mine's hard. This is next time. This is practice one. Alright, you're turning in your lab. Remember, we leave in about 4 minutes. So turn in your lab. You have an idea of what you need to do, but you will practice it fully again another time. We only need to do only the first for now,
Why did you put them away? Yes.
It's perfect.
No, I do not. I can't. I don't feel it.
Well, that's like, okay, it still needs more though. It's like 20. Okay, now it's
We were on our road to Titrations. We just finished. Listen.
it's so. You can do
We slay.
Alex, did you get one?
We slay.
No, I was just.
Me too. Especially pushing me.
It was. What did you get?
Today was practice on experimental procedure. Next time, we're going to have more on your data and analysis. Accurate titration. You would definitely study for your
I get
board.
off on my head. I get out of stuff and take them off.
What glasses are this big?
We're going to do another one. We'll have to do your accuracy and the math.
You messed it up there. What do you mean? I already know what the rating was.
I saw your eyes.
All right, so you got your feet wet with titrations. We will do another one, probably not next week, but right the week after. We'll do another one. Next week, remember, I only see you twice. We will practice
Sorry,
again.
one last announcement. Kiani Sotelo and Rachel Morel, please report to the main office. Thank you.
Start putting everything away. Start putting everything away. Remember to turn in your labs to me. Have a wonderful weekend. Don't forget to study.
Yeah, but exactly at 7:30. But they always
We could have had orange wheels.
And you messed it up for us.
You messed
You
it
messed it up for us.
But I left it our talk drop. I saw it. There was exactly 10.
I counted 10.
It doesn't matter how many drops.
Yeah, yeah.
As long as you make sure it's the same for both ones. That's how we messed up.
It was 10.
Because
I
we'll
put
fight
10.
over
You
difference.
put 10. My 10 were just slightly smaller drops.
You said
But I mean, all the 15 people
gonna be office aide next year. Office aides help me with like cleanup and setup, so that I don't spend hours and hours after school.
I'll be there, Mr. B. I'll be there. Yeah, you can juniors and seniors.
Bye. Just for your rep. Don't worry, we'll practice again another time.
You can see in the picture, like sitting there and being like, we just check every single step. Just to
You'll get more time next time. This was just to get your feet wet, just to see that you understand the experimental procedures. We will do this again. Don't you worry. No stress today. I was just trying to give you something nice on Friday and wasn't. Have a wonderful weekend, everyone. It's been a long week. Get some well-deserved rest. Let me keep my door open. Have a wonderful weekend, Peter. See you next class. Remember, we got the quarterly exam. Study up. Next weekend. Yeah. Oh, the homework, yes. I can't do that at this moment because I have to clean that over the next hour. So you'll have to wait till next week. But I'm going to say that you actually bubbled in the wrong version and you originally had a 30%. And I had to hand grade everything to get you up to the score you got. So just so you're aware. Tutoring is on Monday. So you can check that. You can look over it on Monday. But sorry, I can't do it right now. I have to clean all that up. But I am telling you that I saved you a little bit because you bubbled in the wrong version and I was like, I had to look it over. So I'll let you know on Monday. Come on Monday. Hi, everyone. How was today?